Okay, keep in mind you've got a quiz the next class it's going to be over exponents. So this type of stuff that you're seeing up here. I want to do a couple with you on this. The rest of it will be good practice for you. We did these in class. The base of 16, keeping in mind if I want to simplify fractional exponents, the easiest thing for me to do is to get 16 down to its smallest base. 2 to the 4th is the same thing as 16. So now I have a power to a power, where I get 4 times 3/4 will leave me with 2 cubed, which equals 8. The next one, you've got 25. 25 would be 5 squared, and is raised to the negative 3/2. After that, you can go ahead and simplify that one. 2 1/2. 2 1/2, 2 times 2 is 4, plus 1 is 5, so we got 9 to the 5/2. Once again, 9 has a base of 3, so I got 3 squared to the 5/2. You can go ahead and simplify that. And then this is the last one I'm going to do with you to kind of just make sure we're doing okay on these. Remember, this is a radical. If I want to turn it into an exponent, it'll be to the 1/3. So I have 1 over 4 to the 1/3. And this is all being raised to the negative 3/2, okay? To get this off the bottom, I could make the exponent negative. These two things equal each other. 4 to the positive 1/3 in the denominator is the same thing as 4 to the negative 1/3 in the numerator. And then, of course, this is being raised to the negative 3/2, so after that, a power to a power, you would multiply. If you have any questions about those, just come ask me. The rest of this worksheet you'll be working on after we do our notes. So now we're going to start solving power equations. This could mean that we have a variable in the exponent, or this could also mean that we've got a fractional exponent. Both those ideas we've been working with, okay? So let's start off with this scenario first. When you have same bases, for example, this is b to the x and b to the y. Since those bases are the same, you are able to drop the base and you can set your exponents equal to each other. Keeping in mind that the b's got to be greater than 0 and the b cannot equal 1. For example, why can it not equal 1? Say I have 1 to the 4th and 1 to the 9th. Well, 1 to the 4th is 1 and 1 to the 9th is 1, so those equal each other. However, if I drop those bases of 1 and I set my exponents equal to each other, you'll notice they do not. So that is your reasoning why it cannot equal 1, okay? So you've got to have a greater than 0, but then it can't equal 1. So let's go ahead and go through some of these examples together. Number 1 says 5 to the 2x equals 5 to the x plus 3. Keeping in mind our bases are the same, the base is 5, so therefore we can drop our bases and we can set our exponents equal to each other. At that point, we're just solving for x all the way back to algebra 1 for this skill, and we got x equals 3, okay? Next one, number 2, we have like bases. The base is 7, which means we can drop our base and set our exponents equal to each other. Now we'll get x by itself, divide by 3, and we have x equals 3. Number 3 is a little more tricky. You'll notice the bases are not the same. But we can turn 8 into a 2 by cubing it. Then you got 2x, it's raised to the 2x minus 3, right? Okay, so now keep in mind this right here is a power to a power, so it would be 2, 6x minus 9 equals 2, 3x plus 7. Now I have like bases. So I can do 6x minus 9 equals 3x plus 7. And then at this point I could solve, subtract my 3x, giving me 3x, add my 9, giving me 16, divide by 3, and I got x equals 16/3. The next one, I have like bases again, so I can drop my like bases and bring my exponents down and set them equal to each other. After that, I'm just solving, and now you're reaching back on those skills you've been using for the past several years. So I got 3x minus 3. Don't forget to distribute to the entire parentheses. I got negative 1 plus 2x. So I'll subtract my 2x from both sides, giving me x minus 3 equals negative 1. Then I'll add my 3 to both sides, giving me x equals 2. The next one, once again, you do not have like bases, 7 and 49. 49 could become 7 squared, raised to the 2x plus 1. So now you can multiply these. So I would have 4x plus 2 if I multiplied those. And then this other side, my exponents would be 3x plus 4. Since the like bases were 7, I could drop the bases and set my exponents equal to each other. If I subtracted 3x from both sides, I'd be left with 4 equals x plus 2. Subtract 2 from both sides, and I've got x equals 2. Number 6, same thing. They're not like bases. This could be 5 squared though. So I got 5x minus 4, 5 to the x minus 4. I got 5 squared to the x minus 6. Keeping in mind, we'd multiply those, giving us 2x minus 12. And then this would be x minus 4. So the minute you get your bases the same, you can drop your bases and set your exponents equal to each other and solve. So I'll subtract my x, giving me x minus 12, add my 12, giving me 8 equals x. Next one, we've got they are like bases, so we could do 2, 7x plus 1, 3, 3x minus 2. So here we distribute and get 14x plus 2. Here we get 9x minus 6. I'm going to subtract 9x from both sides, giving me 5x plus 2 equals negative 6. Then I'll subtract 2 from both sides, giving me 5x equals negative 8. Divide by 5, and I get negative 8 fifths. The next one we do not have like bases. As a matter of fact, both of these have to go to a base of 3. So 9 would be 3 squared raised to the 2x. 27 would be 3 cubed raised to the x minus 1. So then I've got this as one of my exponents. Since I got like bases, I can drop my 3's. This would be another exponent. Subtract my 3x, and I get x equals negative 3. Okay, the next one, you've got to take a step before you're ready to do anything with your exponents. So I'm going to add this 1 to both sides, giving me 8 to the x minus 4 equals 64. Now, once again, I got to get these to like bases. So 64 can be 8 squared. Now, I'm going to drop my 8's, and I've got x minus 4 equals 2. So I end up with x equals 6. Okay? So that would be, if you've got a variable in the exponent, how you'd go about it. These are, now I've got a fractional exponent, and you're going to solve these very similar to the way we've always solved, peeling away the layers. So I'm going to start off by subtracting 6 from both sides. So I got 5x to the 1/3 equals 20. Next thing, I can't do anything with this 1x to the 1/3 until I get the 5 away. So I'm going to divide by 5. I got x to the 1/3 equals 4. At this point, if I want that 1/3 to go away, I'm going to raise it. 1/3 times what is going to equal 1, right? Because I want this to end up being x to the first power. Well, if I flip it over and do the reciprocal, these would cancel out, giving me 1. So I'm going to raise this to the power of 3. And if I raise one side to the power of 3, I got to raise the other. These will cancel out, giving me x to the first power. This will be 4 cubed, which would be 64. The next one, you're going to have to divide by 4. So we get x to the 1/5 equals 1/2. Then I'm going to raise this 1/5 to its reciprocal to the 5th power. These will cancel, giving me x, and then I've got 1/2 to the 5th power. 1 to the 5th power is 1. 2 to the 5th power is 32. Remember, the exponent goes with everything in the parentheses. The next one, I'm just going to raise it to its reciprocal. So I'm going to raise it to 3/2, giving me 1/4 to the 3/2. Well, if I get this to a base of 2 squared, that'll get this just a little bit simpler, okay? So now remembering that the exponent goes with everything in the parentheses, well, 1 raised to anything other than 0. 1 raised to the 3/2 is going to be 1. But now I have 2 squared raised to the 3/2. The 2 will cancel, and I will be left with 2 cubed. Well, 2 cubed is going to equal 8, so I end up with 1/8. Next scenario, first step, add the 5. So I end up with 18. To make this 1/2 go away over here, I'm going to multiply by its reciprocal. Notice how those exponents work just like the coefficient. And if I multiply one side by 2, I got to multiply the other side by 2. So I'm left with x to the -2, and this would be 36. To make my -2, I'd flip it over and multiply it by -1/2. So this would also be -1/2. X equals -1/2. Well, 36 would be 6 squared. Then you got -1/2. The 2's will cancel. leaving me 6 to the negative 1. And 6 to the negative 1, the negative just means put the 6 down in the denominator. The next one, I will raise to its reciprocal, which would be negative 2 over 1. Okay? Leaving you with x equals 1/2 to the negative 2. Well, the negative tells me to flip it over, so I end up with 2 squared, which would equal 4. And then our last example would be 4x to the negative 2/3 equals 100. Divide by 4, and I get 25. And then once again, I'm going to flip this over. So I got x equals 25 is going to be 5 squared. And that helps me because it makes these 2's cancel out. So now I'm left with 5 to the negative 3. Well, the negative 3 tells me to put it on the bottom. And then 5 cubed is 125. Okay? So then let's take a look at one of your problems that you have to look at. Just an example of it. Notice the base is 5. So I need to get 1 over 25 to be 5 to the something. Well, to take 25 to the top, it'd be 25 to the negative 1. To get it to a 5, it'd be 5 squared to the negative 1. So that means I got 5 to the negative 2. So 5 to the negative 2 equals 1 over 25. Now you'll notice I have like bases. So I have negative 2x equals x squared minus 24. Well, when you have this type of scenario, you got to look at this and you got to realize it's a quadratic. So we're going to go back once again using all those skills we've learned over the past several years. I'm going to add 2x to both sides because this is a scenario where you have to factor. You won't be able to get x by itself because you've got x squared and you've got x. So now if I were to factor this, 24 would be 6 and 4, and I need that to work out to be a positive 2, so it's going to be x plus 6 and x minus 4. And if you need help with factoring, you need to come ask, because we've covered it this year. You worked on it some before as well, so we can certainly talk about it some more if we need some extra practice. So the answers for that would be negative 6 and 4. A few things to think about here. A radical, you're going to have to raise that to a fractional exponent. This right here is 2/10, which equals 1/5. You're going to have to get that 5 upstairs, which means you need to raise it to a negative 1. Okay? Let me know if you got any questions.